Cool. Thank you so much, James. Boy, I might need a moment after that. Thanks so much. Boy, lucky last, but hopefully not least. How's everyone doing? We're having a good dev world? We're nearly there. We're full of knowledge at this point. Cool. Okay. Hopefully this one will be a nice chew on. There's not a lot of code, but a lot of shiny eye candy. So I hope this is the kind of talk that like really close us out and just be a nice chew on to see us through the end of the conference. So I think James has said most of the stuff here. My name's Tim, but sometimes you might hear other names. Like James said, I'm from Perth, Western Australia. I started attending DevWorld in 2010, back when I was a staff member at ECU, back when it was still the University Consortium. I was a web developer back then, and I saw calls for this. And I just got my iPhone 4, and I was like, this iPhone developer thing seems cool. And so there was calls for DevWorld 2010. I was like, oh, should I go? I don't know. I'm not an iPhone developer, but everyone's like, no, I should go. That'll be a good time. There's this guy called Paris there. He's cool. And I went. I'm very glad I went because I'm still here. So it's such a fantastic opportunity. And again, hats off to AUC and DevWorld for running it for so long and make it one of the most successful iOS Australian conferences there is. I moved from being a web developer, like I did enough side apps to the point where I actually managed to take on iOS development full time in 2013, just as iOS 7 came out, the great flattening happened. And then I actually moved to Japan full time after a few roles in America and Australia to work as an iOS engineer in Japan. And I worked at a few Japanese companies first, but then just out of more or less this complete dumb luck, I ended up working at Instagram in Tokyo in 2022. And it's been absolutely so much fun working at that company, just seeing the sheer quality of folks I get to work with and just like how much blood, sweat, and tears goes on behind the scenes that you don't really get to see most of the time. It's just been fantastic. And finally, I love graphics programming. Before the iPhone was a thing, I actually had a dream of becoming a games programmer. But I think on the all mobile development games are on the same kind of wavelength. But I do love it when my work lets me pretend to be a game developer for a little bit. And this is what I'm going to talk about today, like a cool little thing that we got to build in Instagram last year. I'll just go through. This is going to be a bit more of a process sort of thing and a more behind the scenes kind of look. But I'll talk about three main things. The first one was how did this come to be and how did this happen? Second was how we actually implemented it. And third was the actual mindset, how we arrived at the final effect, because there's obviously a lot of research and like sort of like iteration that goes into this sort of thing. So the first thing as a background was we released a new app. Hopefully you've heard of it. It's called Threads. The idea of Threads is it's another way for Instagram users to express their ideas, to have discussions with fellow colleagues and the likes, sort of like a inversion to Instagram, right? Instagram is like you post a photograph and the conversations follow, whereas Threads is you post text and you can have accompanying images, accessory images, and the discussion flows that way. So it's sort of like another way to express yourself in the same wavelength as Instagram, but in a more textual way. And as you can imagine, this was a really big deal. Like it's not very often that a new member is added to the Meta family of apps, and certainly this is the case with Threads. So obviously the company wanted to go all out. This is a big deal. This is a really big deal when a new app like this comes along. And Instagram's no stranger to Easter eggs. Some folks here might remember back in 2020, Instagram celebrated its 10th year anniversary. And just as a little bit of fun to celebrate that, for a limited time, you could actually go into a super secret settings panel and set your icon back to the OG, or even the OOG, even the prototype app icon that all the iterations that Instagram went through from the very beginning up till now, which is really good fun. And there's a lot of reasons why we love doing this kind of thing. Easter eggs are really fun, right? They let you drum up hype about the app. Like it's a nice little fun little extra slice of delight on top of it. It lets users have a really nice little feeling of exhilaration, pride, when they find this exclusive feature, the secret feature that maybe other people haven't heard about yet. Obviously, like I just said, it makes the app feel a lot more delightful. People have a good time. And one thing that you don't really think about, though, is it's really fun to build these things. It's really fun. So the developers also have a great time building these things. And so when Threads was coming out, we wanted to do the same to try and like give Threads a bit of a boost, a bit of a hype to the launch day. So we're going to do another Easter egg in Instagram leading up to this. And so back then, Threads, we didn't even know what Threads was going to be called back then. So it was public knowledge that the code name was P92. So I was like, we're going to build a golden ticket for P92. And the brief was basically like it's going to be like a spinning holographic ticket that has like a like the reminiscent of like old school baseball trading cards, or like in more modern times, like trading cards with those cool holographic foils. And so this is what it actually ended up looking like for those who didn't actually see it. The main entry point was if you go and search for Threads in the Explore tab of Instagram, a little pink ticket would appear. And if you tapped it, suddenly you get this cool custom ticket that would have your name on it and have your user ID, and now it has the date you joined Threads, and a nice QR code linking to the Threads in the App Store. And so it's this cool little effect of like, this is going to be your ticket off to the new app that Meta's about to launch. As you can see, it has like a lot of nice like holographic foil effects, nice shine to it. It's interactive, like it spins by default, but you can stop it, you can drag it around on your own. You can actually drag it the other way too. It works in both directions. Really high level maths here. And you can also do some cool things like you can flick it. So you can actually just flick your thumb and it'll spin at the velocity you flick it at, and then it'll slow down. And you can flick it the other direction too. And you can see it has this nice dynamically updating shine effect the entire time you play with it. So again, and that's it. Pretty simple. But yeah, as you can see, I'll show you how we built it. So the Threads team was obviously under the pump a fair bit because they were actually trying to get the app ready for launch. So they'd gotten as far as building the front and back sides. These are just 2 UI views, a bunch of UI labels, nothing too crazy here. And they had gotten as far as they hadn't worked out how to make it spin yet. So one of the Threads members just did the standard UI view, card flip transition. I was like, okay, yep, that fits the design spec. That could work. But the Android folks are taking it a lot further. The Android folks are really in on this, and they were actually going to try and make this thing really spin. So one of the Android folks working on Threads came to Japan, and he met the team. So he actually had a chat with my manager, the lovely Will Bailey there to the far right, and was showing Will the spinning effect. And Will has a lot of experience in Instagram, and Will would actually build a similar spinning effect for the Instagram QR codes feature that's in the profile screen. So Will was like, oh, goody, I love this kind of thing. So Will was like, let me help out with the Android version. But if there's no iOS people, like I know I've got a guy on my team who loves like just playing with graphics. I'll ask him to have a look at the iOS version. So Will came to me and said like, hey, I know you like playing with UIs. You want to give this ticket thing a try? I was like, oh, do I? So that's how I got involved with it. So let me go through really quickly. So like not too low level, but hopefully so everyone can understand how we actually went through and implemented all those elements you just saw. So the first step is obviously how do you make it spin with like that sort of 3D perspective and like manual physics-driven control. So making UI views look 3D is actually really easy, but there's a little bit of a trick to it. So just for folks who need a bit of a recap, the actual rendering engine, the graphics engine in iOS is a framework called Core Animation. So it's not actually UIKit, but UIKit wraps Core Animation, and conversely in AppKit on Macs, AppKit wraps Core Animation. So it's a cross-platform framework that then is wrapped by the native frameworks of the platform. And UI View adds extra things like things like springs and struts and tap interactions and guest recognizers, all the nice iPhone things. But the core rendering component is an object in UI View called CA layer. So we'll be talking about CA layer a lot. And so if you drop down to the CA layer level, you can actually apply 3D transforms to the layer component of a UI View. It's really easy. Like you can find this answer everywhere in Stack Overflow. You just need to make a CA transform 3D object. And you modify the M34 property of that one with a predefined formula that creates this perspective effect. You can play with these numbers to make it more FOV, more stretchy, or more close up to the camera. And then once you've created that, you then apply another transformation to it that then rotates along the y-axis. So this is some static code that will just take that view and make it render at a 45-degree angle. Easy enough. And then just like the UI view transition card flip effect, it's like, okay, this is kind of cool, but it's kind of flat still. So let's make it that as we rotate it, we'll just work out what angle it is, and between 0 and 15 degrees, we'll just make it a little bit darker. So it doesn't look great just yet, but this is really important down the line. But as you can see, now we're just adding a bit of extra depth as you rotate it. When it's full on, we want it to be white like a proper ticket, but then once we rotate it, we want the lighting effects to start taking over. Okay, but that's easy enough, but we're not really dealing with UI view animation here. So how do we actually make this how do we animate this? So it's actually a bit more challenging than you might realize, because how UIKit animations work, or how core animations work, is they actually dispatch animations off to a separate process called the core animation render server. And this is interesting because my sample code here, I queue up an animation, and then in the next run loop tick, because if I do it in the same run loop tick, it just blocks the main thread. But you can see that even though the main thread is blocked, the animation still goes through because it's happening off process. This is really good, because even if you've written really heavy, terrible code that's blocking your main thread all the time, animations stay buttery smooth. But we really can't have that here, because we have a much more dynamic thing here. Like this requires animations to have a start and end state. And if you want to modify it on the fly, you have to kill the animation, recreate the animation, reapply it. And we need to have a lot more control than that. So we need something more dynamic than that. Luckily, there's a library that was made for Facebook Paper way back in the day. It's all Objective-C, called Pop. And Pop is a really cool framework that's still used a lot in Instagram and the other apps today. And the way that Pop works is it's sort of like a main thread animation engine. So it lets you set up an animation and then apply it to a layer or a view. And then every single frame tick, it'll give you a callback that will let you update your views. So it gives you per main thread, per tick, ability to update a series of views. on the main thread, which gives you ultimate control because you can modify the animation on the fly. You can update the views, kind of like how UI scroll view works, right? UI scroll view isn't an animation; it's actually happening per tick because it needs that logic to recycle the cells. This is the same concept. Like we're just updating properties on the main thread in sync with the screen. And obviously, this thing gives you a lot of control, like it has animation curves, decelerations, like a ton of really cool controls that you make really fluid designs that are really fluid animations that are interruptible. And so once we moved over to Pop, so Pop has a really cool animation type. There's like, obviously like linear animations and like ease in and out. But there's one called a spring animation that UI View Property Animator also has. And spring animation is interesting because it doesn't actually have an endpoint. What you do is you specify a direction and a velocity and a decay rate, and then just fire the animation off. And then every tick, it'll just apply that decay rate across the velocity. And when the velocity hits 0, then the animation will finish. And so to make that idle spinning animation, all we had to do was apply a spring animation, give it a velocity, give it a direction, because the direction could be rotating either direction, and then just set the friction to 0 so that there's no decay. So the thing will just run forever. And that's all we have to do. So as you can see, all we have to do is there's some pseudocode here where you set up the spring animation and you update the angle on each tick, but you just set the friction to 0 and it runs forever. So a quick demo of what that looks like. So if I set the friction to 1.5, you'll see if you flick it, it'll do the spin, but then it'll actually just stop. And where it stops is completely arbitrary. So it's like pseudo physics driven here. It's just whatever the value was when the decay rate hits 0, that's when the animation ends. And so just just a quick refresher, set the friction to 0, and you get this nice idle looping animation where we can just reapply all the layout code we want every frame tick by doing this through Pop. The one downside of doing this in the main thread, as you can imagine, is this has to be super performant, because if you do anything too heavy, you'll start dropping frames because you're not doing this off a separate thread, like I said before. How we did the actual flicking effect, again, really simple stuff. Have a UI pan gesture recognizer attached to the screen, and then just when you flick it, we extract the velocity from that gesture recognizer. We apply it, we convert it from like screen coordinates to how much we want it to spin. So my logic was one edge-to-edge swipe should be 180 degrees. So using that as a basis, just multiply that by the velocity, and then just go back to the spring animation because it's real time. We can just update it on the fly. We then just set that velocity to whatever the velocity we extracted from the gesture recognizer was. And then the cool thing is to make it actually slow down to spin again, to slow down to that base spinning speed. What we have to do is just keep an eye on what the velocity is after every single tick. And once the velocity goes back to our idle animation again, we just set the velocity back to that base rotation and then just set the friction to 0. And that way we get that nice deceleration effect that then ends with the idle spinning animation. And there we go. So this is how it looks. As you can see, you just flick it. I think it's on the flick it. Yep, you flick it. As you can see, we get this nice idle animation from 2 UI views, just hot swapping depending on the angle. And that's it. Pretty simple, right? Like not a lot of code in the end, but a really powerful effect that makes it really fun to play with. Spend forever like just playing with the spinning animation. So I showed this to the thread designers, and they're like, "Cool. How about the holographic foil effect?" And I was like, "Oh boy, okay. Holy moly, how do we do that? Okay. Just thought about it some more. And I was like, "Oh boy, how are we going to build this thing?" So it's like a lot of like, "Oh geez." Okay, no worries. I think we figured out a way. I got a hunch. Harkening back to my game development days, I was like, I remember like playing with metallic surfaces in game engines. Let me see if I can come up with some nice way of creating this holographic foil effect. So the first thing you should always do when trying to recreate some kind of effect is just do some research, trying to work out what are we even trying to build here? Like, what even is a holographic foil? A good reason for this is obviously if you're trying to create an effect that people recognize, right? Everyone will look at like a credit card or something and recognize the holographic effect. There's obviously a series set of rules or behaviors that this thing elicits that performs that if you show it to a person, this behavior will elicit that recognition in someone. So it's just a bunch of rules. We just have to go through, work out what these rules are, and if we can recreate them sufficiently in code, it'll obviously create the recognition that we want from the users when they see the effect. And so this probably looked really weird to some of my coworkers, but my manager and I, when you live in Japan, you get given a residence card, which is like basically your visa, and that thing has a holographic foil on it. So that's the only thing we had at the time. We're like, okay, this has got a holographic foil. Let's just go into a meeting room, turn the lights off, put one of them down on the table, and then just run our iPhones over it, simulating like if the light source was changing on a rotating device, rotating card, and just see how the effect actually behaves. Again, it looks really weird when there's 2 people in a meeting room with the lights off, but and I would like to show a video, but like there's a lot of private information on that card, so I was like, I can't Photoshop it out for every frame, but hopefully you can play along if you have a credit card or something that has a holographic foil on it, you can see what the behavior looks like. But by doing that, we just had a few key takeaways that we're able to take and work with. The first one is obviously holographic foil is just like a rainbow gradient, right? It's just a rainbow gradient that changes color, like slides around as you move the light source around. And it's always like clips to a shape, right? Like on credit cards, it'd be like a rectangular shape. There's like a specific shape that clips this gradient effect. And because of the way the light's reflecting, it always seems like irrationally over the top bright. Like even in a dark room, it's an extremely vivid sort of effect you're looking at. So that's what we had to go with, like sliding gradient, super bright. I was like, okay, hopefully that'll work. After that, definitely what you should do before you try and brighten your code is do some prototyping. It's still up on the Apple website. There's a really, really good talk from WWDC 2014 called Prototyping, Fake It Till You Make It, with the general gist being like, you think you can picture something in your head exactly how it will be in reality. Like you might think you've got this really nailed down, but until you've got it in front of you and you can actually play with it and touch it and interact with it, maybe what you're imagining is not exactly how it will work out. Or sometimes it's exactly how you work out, but maybe it's because of the animation or whatever, it actually feels not great. So something Apple really recommends is try and get something of your design or your layout out on paper or whatever as soon as possible. Like Apple even recommends just use Keynote because Keynote has built-in animations and shapes. You can make a really quick mock-up of an app or something in Keynote. Just get it out there so you can play with it and see what it feels like. And hopefully, if it looks good, you can be like, okay, now I can commit to doing this, committing tons of hours of coding to actually make this thing a real thing, as opposed to doing all the coding first and then realizing you're barking up the wrong tree. So the way I prototyped the foil was this is some premium Photoshop here. I made a budget-looking Threads logo in Photoshop. Then I made a gradient layer on top of it, and then I clipped the gradient to the logo's mask, and then I locked the mask in place, and then kept moving the gradient around by just dragging it around. And I was like, okay, yeah, that's giving off holographic vibes. That's a bit holography. Okay, this might actually work. Okay, alrighty. So there you go, really premium prototyping skills here. Seems possible. Okay, I'm excited. Let's give this a try. So next thing is like, how do you actually do this? Like, how are we going to do this in code? So CA layer, there you go, one anvil for the day. CA layer has this ridiculously good API. I think this API basically carried the whole effect called Contents Rect. Has anyone here heard of Contents Rect before? One, Adam, there you go, two. Excellent, okay, good. Good thing I got this in here then. Context Rect is a really powerful API. It is so cool. Basically how it works is when you apply an image to a CA layer, obviously it just crams the whole image into the CA layer. But what you can do is you can actually set a sub-region of that image to stretch out to the whole region of the layer. This is really cool. For a good example, this is like games where you have like an entire series of sprites in one texture, and like you want to animate the sprites by just changing the visible region of the texture. Like this lets you do that with CA layer. So just as a visual example, if I made an image that was just a grid of numbers, and then assigned it to a CA layer, and then obviously the default value is the top left is 0, 0, and the bottom right is 1, 1. It's normalized coordinates. So if I change the first two values to 0.5, 0.5, suddenly we'll blow up the lower right quadrant and show that quadrant of the text of the image. Or conversely, it doesn't actually have to be consistent. Like you can do the first two is 0, but if the x component is 0.5, what you'll get is you'll get the first vertical half of the image stretched across the entire layer. So hopefully you can see where I'm going with this. So the next step we did was we used Core Graphics to generate a very simple image of the Instagram Instagram branded gradient colors. But then we just bumped up the brightness and saturation so they would sort of look like they're an over bright holographic gradient. Like the dark blues and the purples of the Instagram logo wouldn't work as a bright color. So we just bumped it up. And then we just copied and pasted the code twice to duplicate it. So we had one that was an extra long one. And then using CA layer Contents Rect, we changed the visible region of this one to just be half of it. And as you can see, half of it's basically the same shape as the golden ticket. And then all we had to do is on every frame tick, of whenever Pop called a frame tick, we'd get the current angle between 0 and 90 degrees. And then as it was rotating between 0 and 90 degrees, we just slide the visible region from one end to the other. And that's it. And so what does that look like when you apply it to the ticket? You get this effect. It's like, okay, so now we're getting a sort of it's very vivid, very over the top, very extreme. Made a simple little masking texture, which was just the Threads logo 4 times. And thankfully, I didn't have to make a giant a giant pattern of this. I need to do it once, and then you can use a really cool API of UI color that lets you define an image as a pattern, and then that will just duplicate it over many times across the entire layer. And so then we set that as the masking layer of that intense gradient layer. And what happens is the mask stays in place, but the contents rec still slides around. So suddenly we get this effect. So as you can see, now we've got like a proper looking like holographic foil sort of effect where we have clipped shapes that expose the gradient, and the clipped shape stays in place, but the gradient is actually sliding around. So now we're getting a really nice looking metallic holographic effect. It still doesn't look great though, because what's happening here is we're not really getting that over the top brightness of what we expect of a holographic foil. So there's one little last touch we can do here. This is an undocumented API. We're gonna have a debate later if it's a private API, but it works without doing anything sneaky. You can actually set blending modes on CA layers. So there's an API called compositing filter, which just takes a string, and it's just like Photoshop. You can do things like screen, multiply, burn, things like that. But overlay is the most intense one. Overlay like multiplies it over the background color. And suddenly now you can see why gray becomes necessary, because if it was pure white, you can't multiply color over pure white. Like you can't get more white than pure white. So now the gray background actually like lets you see the holographic foil effect, whereas on pure white you wouldn't. But as you can see, now we've got this nice thing where it's actually looking a lot more vibrant and intense. Okay, that's looking pretty close to being done, but there's one more thing. I think the problem is now we're looking at this effect. It's not that like compelling, right? Like it's still very flat. Like like the second it turns, you've got this really flat looking effect where like the color doesn't change anymore. But the foil's definitely doing a lot of the heavy lifting, but it still looks kind of muddy. Like there's not a lot of depth in this thing still. So what can we do to try and make this thing look a little bit more compelling? Basically, what I'm thinking, what we decided here was there's some kind of subversion of expectations. Like the foil was kind of like making everyone think that it looks shiny, but the fact it's on like a flat matte gray kind of like removes that expectations. Like it's like it should be shiny, but it's not shiny. So how do we actually make this look a little bit nicer? So harkening back to the computer graphics in the 90s, making these look shiny is really easy. You just add these little white highlights on something, and these are called specular highlights. Specular highlights are basically supposed to be the reflection of a light source bouncing off the surface. And as you can see, what that does is it just elicits this recognition this is a shiny object. And so really simple again. All we had to do is we just went back into Core Graphics, made another little texture with two components. The first was a big round circular gradient, which was creating like creating like sort of like that was supposed to be the specular highlight. But then just to make it look at not flat and muddy, we added two linear gradients. There was one that was at the beginning that kind of like slided out as the middle specular highlight slides out. But then to stop it from being permanently gray once we've gone past that bit, another gradient on the other side slides in as the other one's sliding out. So as a result, there'll be no point on the card, on the ticket, that'll be like a solid, consistent color. There'll always be some kind of like rim lighting or simulated shiny lighting. And we just copy and pasted the same codes. We did the exact same thing with the gradient layer, just sliding from one side to the other as the card rotates. And let's see what the final result is. And there we go. We have a specular highlight sliding out of the way to reveal the holographic effects, the masking effects. And then as it rotates all the way to 90 degrees, you'll see a little bit of like highlighting, rim lighting comes in from the very edge as well. And that all adds up together to create the final effect. So as you can see, it's three separate effects, kind of like moving independently of each other that contribute to the final looking effect. Yeah, well, thank you. Thank you. Yeah, with that, we're done. Just a quick recap. So there you go. So it's like 4 steps, right? Step 1, dim the card. Step 2, add a really intense gradient pattern. Step 3, apply some blending and masking so the gradient is clipped to the mask, the threads logo. And then step 4, seal it all in with a specular effect that kind of makes the whole thing look shiny like a proper ticket. And it was well worth the effort. So this leaked to the public by Zuck just casually dropping in his stories like, hey, you should try putting threads in search and see what happens. That just pushed the snowball down the hill, which was amazing. We had like Forbes reporting on it. We had CBS reporting on it. It was so good to see on Twitter. People be like, "Oh, hey everyone, I just found my own ticket in Instagram. Here it is. Here's a screenshot. Oh boy, this is so cool." It was so good. And we definitely saw on the metrics that this definitely had a noticeable impact on pre-orders for the Threads app in the App Store. So a lot of folks tapped that Open in Threads button, or go to the App Store at the time and signed up for it. So it was definitely well worth the effort, and it was very well received, and we're very proud of what the outcome was. So I'm not really sure what the moral of the story is, I guess, but in summary, like Easter eggs are fun. They're a great way to add hype and delight to your app. You got to be careful sometimes though. Like Apple doesn't like Easter eggs because they don't like hidden functionality. So definitely, make sure it's either harmless or you tell Apple about it. But a lot of the takeaways I want to give away for this talk is like, don't try and guess when you're trying to do this kind of stuff. Like, do research, collect reference material, prototype your ideas. Don't just go in and just start coding for the sake of coding. Actually try and work out what it is you want to build ahead of time. You'll save yourself so much time down the line by doing that. And if you haven't really looked at core animation, I know Swift UI does a lot of this stuff as well. I think Swift UI probably does more than core animation these days. But there's so, like you saw of Contents Rex, there's some really, really cool APIs in CA layer that you can do some really cool effects with. That's just scratching the surface. Like I'd love to do another talk on just other cool effects you can do with CA layer. But the most important thing is just have fun. Like building this kind of thing is really good fun. It shows folks that the developers are having a good time, because we were. And yeah, just go for broke and have a good time. And if you make anything fun, please show me. And on that note, thanks so much for listening. Here's I happen to be on Instagram and Threads, if you could believe it. And if not, you feel free to hit me up on LinkedIn, send me a message there. And thank you so much for your time.